In this podcast, we'll delve a little bit more into solving absolute value inequalities. And what I'm going to do is I'm going to use the same problem example for type 2 and type 3 so you can clearly see the difference in a less than problem versus a greater than problem. So let's begin with the less than problem. We know that there are three rules to get, we know we can't solve for x until we get x out of this grouping symbol. So we got to get rid of that grouping symbol, the absolute value bar, and we discussed last time the three rules for removing the absolute value bar. Now this is case 2, rule 2. What happens when you have the absolute value of m? I left my absolute value bars off here. What happens in rule 2 when you have the absolute value of m is less than k? Well, first off, I don't have that. I have a less than, but I've got a whole lot more over here on the left than just the absolute value bars. So the first thing I have to do is get rid of that so that all I have on the left is the absolute value. So I add 4. And I get 2 absolute value of 3x plus 1 is less than 14. I divide by 2. The 2's cancel. And I get the absolute value of 3x plus 1 is less than 7. And notice I haven't done anything to remove the absolute value bar, so I still have the absolute value bar. Now I go up to apply rule 2, which is what happens when all you have on the left is the absolute value and on the right a constant. Well, rule 2 says if you want to remove that absolute value bar, write negative the constant is less than the mess is less than the constant. So that's what I'm going to say. Negative the constant is less than the mess is less than the constant. And I'm just going to solve that out. Now, to solve a regular inequality, you do the same thing to both sides. If it's a three-sided inequality, you do the same thing to all three sides. So I'll say minus 1, minus 1, minus 1, and I get negative 8 is less than 3x is less than 6. And then to get x by itself, I divide by 3 again to all three sides. Divide by 3 on all sides. The 3's cancel. So in the middle here, I'm going to get x. On this side, I get negative 2 and 2/3. On this side, I just get 2. So I get x is between negative 2 and 2/3 and 2. Notice the 2 is bigger than the negative 2 and 2/3, and it has to be. Small numbers on the left, big numbers on the right when the inequalities point this way. Let's see what the graphical answer would look like. I'm saying x is between negative 2 and 2/3. Well, here's negative 2. If I break this piece into 3 pieces, this would be negative 2 and 2/3 right here. And x is bigger than that, so it's to the right of it, so I'm going to make my bracket go to the right. But x is, and I made it curved because there's no equal to bar here, so x can't equal this, so that's why it's a curved bracket. Now on the other side, I have x is equal to 2, or not x is equal to 2, but it's smaller than 2, and it can't equal t, so again I use a curved bracket. And the solution set is all the points between the brackets. And if I write that in interval notation, I just drop out the graph. I have curved bracket negative 2, comma, 2 curved bracket. Interval form, graphical form, inequality form. Okay, let's go to the next case. Case B, same set. Woo, not same setup. I left out the minus 4, so let me put that in there. This time I'm going to do a greater than or equal to just to show you the difference in the graph. And now we're looking at case 3. Case 3 is the greater than case. And the issue is, well, how do you use case 3 to remove that absolute value bar? Well, you can't until the absolute value is by itself on one side. So I first get rid of the 4, just as I did in the other case. So that's going to be greater than or equal to 14. and that's going to be 2 times the absolute value of 3x plus 1. Now I get rid of the 2, and I get the absolute value of 3x plus 1 is greater than or equal to 14. Haven't done anything to get rid of the absolute value. It's still there, but now I am in the form for Rule 3. And Rule 3 says if you have the absolute value of a mess is greater than k, and by the way, that works for greater than or equal to, and this one up here works for less than or equal to. If I have the absolute value of m is greater than or equal to k, then I write either the mess is greater than or equal to k, or the mess is less than or equal to negative k. I hope this is showing up on the screen. I'll move it over in the next line to make sure it shows up. Now I start solving the one on the left, so the first thing I want to do is subtract 1. So I get 3x is greater than or equal to 13, or, oh, wait a minute. I'm sorry. When I divided both sides by 2, that should have been a 7. So this should be a 7, and this should be a 7, or a negative 7. So this, then, if I'm subtracting 1, should be a 6. So I get x is greater than or equal to 2. On this side, if I subtract 1 from both sides, I get 3x is less than or equal to negative 8. Negative 7 minus 1 is negative 8. I divide both sides by 3. Now notice I'm dividing both sides by positive. It doesn't matter that I get the answer negative 8/3. It matters what I do. And I'm dividing by positive, so I do not flip the inequality. So I get x is less than or equal to negative 2 2/3. And this is real important. This is an or. It means I have a solution anytime x is greater than or equal to 2, or x is less than or equal to negative 2 2/3. Now I locate the same numbers on my graph. Here's negative 2, negative 3, so this would be negative 2 2/3. That's 0, that's 1, that's 2. And the solutions are all numbers greater than or equal to 2. So since it can equal to, I use a square bracket. Since it's greater than, I arrow to the left. Or all the numbers less than or equal to negative 2 2/3. So again, I use a square bracket. Sorry, here I arrowed off to the right. Here I arrow off to the left. And there's my graphical form of the answer. Here's my inequality form. Here's my graphical form. And now I need a interval form. Well, these numbers in this first set start with negative infinity, and infinities always get a round bracket, and it goes all the way up to negative 2 2/3, but now that's going to get a square bracket because it's less than or equal to negative 2 2/3. Now the or means union, so I put a union sign here. So that's why it's so important that you keep track of this word here, because if you don't know what symbols to use, whether to use the union symbol or the intersect symbol. And then the second set starts at 2 and goes all the way to infinity. Rounded at infinity because infinity is not a number. And there's a nice contrast between a less than inequality and a greater than inequality, and that completes the podcast.